1 revolution. On a circle. Now, one note I want to make is just make sure we're clear on what a revolution is in the systems of measurements that are commonly used. So a revolution is 360 degrees. It's also 2 pi radians, and it's also approximately 6.28 radians. And that would be using 3.14 as an approximation for pi. Now, essentially, the strategy here is to find out how many revolutions are in the angle, back those out, and see what's left over. Because the full revolutions are really just sort of a matter of spinning around the circle. What really tells you where you are is what's left over. So what you want to do for each of these angles that are greater than 1 revolution is you want to divide the given angle by the equivalent of 1 revolution in the system of measurement being used, and then look at the part that's left over. So let's do some examples. Example 1. Suppose you were given 842 degrees. So as you look at that, you know that's more than 360 degrees. So in essence, you want to see how many sets of 360 are there in 842. So you do a division, which of course you could do on your calculator. And you'll get 720. When you look at what's left over, you have 122 degrees left over. So essentially, 842 degrees is 2 revolutions of 360 with an extra 122 degrees left over. And so then, when you go to find that, you're looking to first we're looking at the positive direction. We're going about 122 degrees, somewhere in there. So what you've done is gone 1 revolution, 2 revolutions, and then 122 degrees. Okay, example 2. Negative 416 degrees. Again, you can see that that's more than negative 360 degrees, so you've gone more than 1 revolution. So you want to back out the revolution. So you say, well, how many sets of 360 are in 416? And I always work with positives when I'm doing my arithmetic, and then make the leftover negative what I'm looking for. So I divide 360 into 416, and basically that's going to be about 50-60 degrees left over. So this is going to be 1 revolution plus another 56 degrees, but in the negative direction. So 56 degrees in the negative directions, maybe somewhere here. So essentially what we're doing is we're going 1 full revolution in the negative direction, and then another negative 56 degrees. So we're at negative 416 degrees. Example 3. .7 radians. Now that's more than 6.28 radians. So again, we want to back out what's a full revolution, or however many full revolutions. So you want to find out how many sets of 6.28 are in 9.7. And we need to add a 0 there, so we have so it looks like we're going to have 3.42 radians left over. And so what this essentially is 1 revolution plus 3.42 radians out of 6.28. So what's left over is 3.42 radians out of 1 revolution. Where is 3.42? Well, we know this is 0, 1.57, 3.14, and of course we know these, we went over these in part 1 of Where Am I? So 3.42 is a little bit past that, maybe somewhere here, and so what we're looking at is 1 revolution, and then the 3.42 radians. So we're at 9.7 radians. Example 4, negative 12.9 radians. Again, that's more than negative 6.28 radians, so it's more than 1 revolution. We want to figure out how many sets of 6.28 are in 12.9. And so you'll have about 0.34 radians left over. So essentially what you have is 2 revolutions, and then another 0.34 out of 6.28 revolutions, all in the negative direction. So you're really saying 0.34 radians out of 1 revolution. And then don't forget, in the negative direction. So negative 0.34. Well, remember, this is 0. We're going negative direction. This is negative 1.57. So 0.34 out of 1.57 is, if you're rounding quite a bit, it's like, you can think of it as 3/15, so about 1/5 or so. A little bit of rounding there, but this is just an approximation. So essentially we're going in the negative direction, 2 full revolutions. So here's 1, 2, and then that little extra bit, it's the 0.34 radians. So this would be negative 12.9 radians. Example 5, 25 pi over 7. Again, 2 pi is a full revolution, and in sevenths that would be 14 pi over 7. So we obviously have more than 14 pi over 7, so this is an angle that's basically more than 1 revolution, and we want to figure out what this really is. So let's divide 7 into 25 and figure out how many pi's we have. So let's see. So essentially, 25 pi over 7 is the same thing as 3 4/7 pi, which we can think of as 3 pi plus 4/7 pi. Now, the 3 pi really is 2 pi plus pi, and we want to back out all the full revolutions. So that's 2 pi plus another 1 pi plus the 4/7 pi. This is 1 revolution, and this is what's left over. So we really want to look at is the 1 4/7 pi. Where is that? Well, going in the positive direction, this is pi, starting at 0 degrees, or 0 radians. And then we want to go another 4/7 pi from here to here. So we got to here. So we got to divide this into sevenths. 1, 2, 3, 4, 5, 6, 7. So counting 1, 2, 3, 4 sevenths is right about there. That pi. So we're going to end there. And what this looks like is 1 revolution, and then another 1 4/7 pi. So this is 25 pi over 7. And our last example, example 6, negative 22 pi over 5. Again, this is more than 1 revolution in the negative direction because we're dividing this by 5. So we would have a full revolution would be 2 pi or 10 pi over 5. In the negative direction, negative 10 pi over 5. But we want to find out, what do we really have here? So divide 5 into 22. So essentially, you have that 22 pi over 5, if this were positive, is the same thing as 4 and 2/5 pi, which is 4 pi plus another 2/5 pi. Now, this part, the 4 pi, is 2 full revolutions. This is what's left over. So we want to go ahead and figure out what's 2/5 pi in the negative direction, and that will tell us where we're at. So we're going in the negative direction, and we want to divide this into fifths. 1, 2, 3, 4, 5. And we're picking here at negative 2/5. And so essentially we're going 2 revolutions in the negative direction. Negative 1, negative 2, and another 2/5. So this is negative 22 pi over 5. Well, thank you very, very much for listening.